Now, students, we will discuss the next topic, that is the factors affecting the ionic bond formation. Right? So, the next topic is that what are the factors which affects the ionic bond formation. So, you have gone through that the ionic bond formation, it takes place in three steps. The first step is the loss of electron, second step is the gain of electron, and third step is the attraction or the attraction between the two oppositely charged ions which have been formed in the above two steps. Right? So the factors will be on the basis of this step only. The first step was that there is a loss of electron by an atom. Now students, which periodic property is related with the loss of electron? It is ionization enthalpy, right? And second step was the accepting of the electron. Now you know that the property periodic property which is related with the acceptance of electron is the electron gain enthalpy, right? And the third step, that is the attraction between the two oppositely charged ions to form a ionic compound, is related with the lattice enthalpy. That is new to you, but like ionization enthalpy and electron gain enthalpy, we have discussed it in the last video. So we are going to just utilize the concept of these two here in the formation of the ionic bond. So what is the first step? The first step is the loss of electron, and that is related with the ionization enthalpy. Now, but for the formation of the ionic bond, right? So the ionization enthalpy, that is the energy required by an atom, right, to get its outermost shell electron removed to form a stable gaseous cation, is known as ionization enthalpy, right? So if the energy will be required less, if the energy will be required less, that means more easily the cation will be formed, right? So ionization enthalpy for the formation of ionic bond, the magnitude of ionization enthalpy of an atom should be less. So if the ionization enthalpy will be less, more smoothly the atom will use the electron and will get changed into a gaseous cation. Right? Now the second factor is the electron gain enthalpy. Right? So what was the electron gain enthalpy? It was the energy that is involved when an electron gets added to an atom to form a gaseous anion. Right? So here, if there will be more tendency of an element to of an atom to accept an electron. So what will happen? Its electron gain enthalpy value will be more negative. Right, students? So hence the electron gain enthalpy, if it is exothermic in nature, right, there will be formation of the ionic bond easily, right? If the its value becomes less and less negative, the tendency for the ionic bond formation will also decrease. So electron gain enthalpy, right, it is here that for the formation of the ionic bond, the magnitude of electron gain enthalpy should be more negative, that is greater tendency to accept an electron, right? Now students, here only if you take electron gain enthalpy, if you take the formation of an oxide ion, right? So if generally one oxygen atom, right? So if it is accepting an electron, right? So it will form O negative ion, right? I'm just writing this case here. That is, if it is O, it is will accept one electron, right? And it will form O negative ion. The second step, right, it will accept one more electron and will form O2 negative ion, oxide ion. So in the first step where oxygen is accepting an electron to form an oxide ion, right, it its value, right, is, we can say it is negative electron gain enthalpy, right? But when the one more electron is getting added, so here it is O negative, this is also negative. What will happen? There will be repulsion between these two. As a result, there will be lesser tendency to accept that electron by the anion. So the energy will be required there to, we can say, to get this electron added here, right? But finally, when we add these two electron gain enthalpy, right, we get the negative sign for the oxide ion formation. That is the sum of electron gain enthalpy first and second comes to be negative. That's why the oxide ion formation is favorable. O2 negative ion is favorable, right? So the magnitude of electron gain enthalpy, it should be more negative, or it should be negative so that the anion formation takes place, right? Now the third factor is the lattice enthalpy. Now this is related with the electrostatic force of attraction between the two oppositely charged ions, which will bring them together. So the third factor is the lattice enthalpy. So what is lattice enthalpy? It is the amount of energy, or it is the energy released. Also you can write down, it is the amount of energy released to form 1 mole of ionic compound amount of energy released to form 1 mole of ionic compound by the oppositely charged cation and anion. Right? We'll see that lattice enthalpy is the energy released when the two oppositely charged ions, they will just come closer to form 1 mole of a compound or 1 mole of a ionic compound. Right? Since we're discussing here the ionic compound, so it's 1 mole of ionic compound. Right? Now, lattice enthalpy. That is when we are saying the two opposite charges A plus and B negative, they are coming closer. That kind of energy which will be released. So that means more is the energy released, right? More stable will be the ionic bond form. So more is the energy released, more stable is the ionic bond. right? Now the lattice enthalpy of a compound, it depends upon the two factors. The first one is the charge on the charge on the species, and second it depends upon the size of the species, right? So that is enthalpy, it depends upon the charge on the species and the size of the species. So here the lattice enthalpy, it depends upon charge and size of ion, right? So this is there. Now the charge of the ion means greater is the charge, more will be the attraction, right? And hence greater will be the energy released, right? The charge, if the magnitude of the charge is high, for example, if we have A plus and A plus and A2 plus. Now if we discuss these two factors which affects the lattice enthalpy. So first was the charge. That means students, if we have A plus and A2 plus, definitely the energy, the lattice enthalpy of A2 plus is going to be high. So greater is the charge on the ion, greater will be the lattice enthalpy, right? Second is the size of ion. So if we compare this, so among this is going to have the greater lattice enthalpy. The size of the ion, now here, bigger the size of the ion, right? Bigger is the size of the ion. So what will happen? There will be internuclear distance will be more, and hence the force of attraction is going to be less, right? So that means bigger the size of ion, larger is internuclear distance, and hence less attraction. So if the attraction will be less, so what will happen? Less lattice enthalpy, right? So the magnitude of lattice enthalpy, it should be always more amount of energy should be released, its value should be negative, and the magnitude of lattice enthalpy depends upon the charge. Greater is the charge, more will be the energy that will be released, because stronger is going to the attraction, whether it be a cation or whether it be a anion, right? So if we just have B negative and B2 negative, definitely nuclear the attraction, right, comparatively is going to be more, right? So it depends upon the charge. Okay, now let me here mainly focus on here the nuclear charge, right? That effective nuclear charge. Yes, effective nuclear charge of this ion is going to be more, A2 positive. Now size of the ion, bigger the size of the ion, larger the internuclear distance, right? That means the two ions separation will be more, so there will be less attraction, hence the magnitude of lattice enthalpy is going to be less. Now just in a nutshell, we are going to just conclude here that for the formation of the ionic bond, right? The formation of the ionic bond. So we can conclusion here is that for the formation of ionic bond, the sum of the electron gain enthalpy and the lattice enthalpy should be greater than the ionization enthalpy, right? So for the formation of the stable ionic bond, or for the easy formation of the ionic bond, the electron gain enthalpy, the sum of electron gain enthalpy and the lattice enthalpy should be always greater than the ionization enthalpy. Right? So just go through it and get it noted down in the notebook.